Download this code from codegive.com, link in the description below. Virtual destructors in C++, a comprehensive tutorial. Virtual destructors are a crucial concept in C++ object-oriented programming, especially when dealing with inheritance and polymorphism. They ensure proper memory deallocation when deleting objects through base class pointers. This tutorial delves into virtual destructors, explaining their purpose, how they work, and providing detailed code examples. 1. The problem: resource leaks with polymorphism. Consider the following scenario. Output asterisk. Observe the output. The derived class destructor, derived, is not called. This is a problem. The derived class allocates memory, using resource equals new int 10, in its constructor, and the intention is to release this memory in its destructor. However, since only the base class destructor is called, the dynamically allocated memory for resource in derived is never freed, leading to a memory leak. Why does this happen? When you delete an object through a pointer to the base class, the compiler uses the static type of the pointer, which is base asterisk in this case, to determine which destructor to call. The compiler doesn't automatically know that the object pointed to is actually a derived object. Without any indication otherwise, it assumes it's dealing with a base object and calls the base destructor. 2. The solution: virtual destructors. To address this issue, you need to declare the base class destructor as virtual. The virtual keyword in front of a member function indicates that the function's behavior can be overridden in derived classes, and that the appropriate version of the function to call is determined at runtime, dynamically, based on the actual type of the object. Let's modify the base class. Output asterisk. Now, the derived class destructor is called before the base class destructor, ensuring that the dynamically allocated memory is properly released. Explanation asterisk. 1. Virtual destructor declaration asterisk. By declaring base as virtual, you tell the compiler to use dynamic dispatch, runtime polymorphism, to determine which destructor to call when deleting an object through a base asterisk pointer. 2. Dynamic dispatch asterisk. At runtime, when delete base ptr is executed, the program checks the actual type of the object pointed to by base ptr. In this case, it's a derived object. Because the destructor is virtual, the most derived class's destructor, in this case, derived: is called first. 3. Chaining of destructors asterisk. After the derived destructor executes, the destructor of the base class is automatically called. This ensures that the destructors of all base classes are called in the correct order, from most derived to least derived. 3. Why virtual destructors are important. Asterisk. Prevention of resource leaks asterisk. As demonstrated, virtual destructors prevent memory leaks by ensuring that destructors of all derived classes are called, even when deleting objects through base class pointers. Asterisk. Proper resource cleanup asterisk. Virtual destructors guarantee that all resources, memory, file handles, network connections, etc., acquired by derived classes are properly released when an object is destroyed. Asterisk. Polymorphic behavior with inheritance asterisk. When using inheritance and polymorphism, virtual destructors ensure that the correct cleanup routines are executed based on the actual type of the object, not just the type of the pointer. 4. Rule of thumb: make the base class destructor virtual if the class is designed for inheritance. If you intend for a class to be used as a base class in an inheritance hierarchy, always make its destructor virtual. This is a best practice that prevents potential resource leaks and unexpected behavior. 5. More complex example. Let's consider a more complex example with multiple levels of inheritance. Output asterisk. As you can see, the destructors are called in the correct order: square, rectangle, and then shape. Without the virtual destructor in shape, only the shape destructor would be called, potentially leading to problems if rectangle or square held dynamically allocated resources. 6. Virtual destructors and abstract classes. Even if your base class is abstract, contains one or more pure virtual functions, you should still declare its destructor as virtual. An abstract class might still have resources that need to be cleaned up by its destructor, and derived classes will inherit the virtual destructor property, ensuring proper cleanup in polymorphic situations. 7. Caveats and considerations. Asterisk overhead asterisk virtual functions, including virtual destructors, introduce a small overhead because of the virtual function table, VTable, lookup during runtime. However, the benefits of proper resource management far outweigh this minor overhead, especially in complex systems. Asterisk multiple inheritance asterisk when using multiple inheritance, the rules regarding virtual functions and destructors become more complex. Carefully consider the inheritance hierarchy and ensure that the correct destructors are called in the appropriate order. Asterisk copy constructors and assignment operators asterisk when you use virtual destructors, it's a good indication that you might also need to define copy constructors and assignment operators for your classes to handle deep copies of resources. This is related to the rule of 5, or rule of 0/3/5. 8. C++11 and the override specifier. In C++11 and later, you can use the override specifier when defining a virtual function in a derived class. This helps the compiler to catch errors if you accidentally misspell the function name or have a different parameter list, which would prevent the function from actually overriding the base class version. 9. When not to use virtual destructors. While using virtual destructors for classes designed for inheritance is a general best practice, there are cases where you might choose not to use them. Asterisk final classes asterisk if your class is declared as final, using the final keyword in C++11 and later, it cannot be inherited from. In this case, you don't need a virtual destructor because there is no possibility of deleting the object through a base class pointer. Asterisk classes not designed for polymorphism asterisk if you have a class that you specifically designed to not be part of a polymorphic hierarchy, example a simple utility class or a pod, plain old data structure, there's no need for a virtual destructor. Adding one would only introduce unnecessary overhead. However, even in this case, consider the possibility of future changes to the design. 10. Summary. Asterisk virtual destructors are essential for preventing resource leaks and ensuring proper cleanup when deleting objects through base class pointers in inheritance hierarchies. Asterisk if you intend for a class to be used as a base class, always make its destructor virtual. Asterisk virtual destructors ensure that the destructors of all derived classes are called in the correct order. Asterisk using override helps prevent accidental errors when overriding destructors in derived classes. Asterisk while there are a few edge cases where virtual destructors might not be necessary, they are generally a good practice to follow for classes designed for inheritance and polymorphism. By understanding and utilizing virtual destructors correctly, you can write more robust and reliable C++ code that properly manages resources and avoids memory leaks in complex object-oriented systems. Always consider the potential for inheritance when designing your classes and make the appropriate decisions regarding virtual destructors. Remember to also consider the rule of 5 when dealing with classes that manage their own resources.